Alright guys, so we're on chapter 3, section 6. This is the derivatives of inverse functions. Very quickly before we start taking notes, what do you recall about like a function and its inverse? So if you have a function, there's some requirements in order to have an inverse. Do you guys recall what they are? It should be able to reflect over y equals x. Keep that, like as simple as that sounds, keep that in mind. Remember how easy inverses were, that simply if you have an x value on your f function, that becomes your y value on your inverse. So in other words, the x and the y values would trade places, right? But does every function have an inverse? No. There was a way to determine if a function did have an inverse. Do you guys recall that? That was to determine if it was even, odd, or neither. Something like that. It has to do with composition. If I can check that they're inverses by doing composition, like f of the inverse and then the inverse of f, and if the result gives you x, then they were inverses. But what if you just have a function? Like if you just only have the function, and I'm only asking you, does it have an inverse? There's a test graphically. Not the vertical, the other one. The horizontal line test. So if you don't remember that, write it on your notes. In order to have an inverse function, you must pass the horizontal line test, which means that your function has to be 1 to 1. Okay? So write that down on your notes. So to have an inverse, the function must be 1 to 1. And horizontal line tests, right? So it needs to pass the horizontal line test. But then your question is like, well, forget that. That means I have to grab this thing. Agreed? And then I have to check if it passes the horizontal line test or not. Then your question becomes like, is there a way for me to tell algebraically? Well, technically yes, but it's going to require a lot of work. Okay? Remember, you would have to do all the steps, which is switch your x and your y variable, solve for y, then do the composition. If it gives you x, then there would be inverses. You guys recall all that from pre-calc? Well, in the calculus test, they're not going to test you over that. That was pre-calc. So they're going to assume that they're going to give you something that will have an inverse. Okay? So you're not going to have to check that it has an inverse. It will have an inverse. But it is good to know, for you to remember how to check if it has an inverse. So let's go ahead and get started. So let f be a function whose domain is in interval I. So you have a function and the domain is in some interval. If f has an inverse, then that means that if f is continuous on its domain, then what can you tell me about the inverse? Cool. It will also be continuous. And I like how you try to make the variables, but that means that it's still going to be continuous over its domain, its own domain. Okay? So yes, I agree with you that the domain of the function of f becomes a range, but technically if we're talking about the domain of the inverse, it should still be continuous, which in your case would be the y of f of x. Agreed? Okay. If f is differentiable on an interval containing some c value, and f of c does not equal to 0. Okay, so if it is differentiable on an interval and on that interval there's some value in between that interval, if you can differentiate that and then evaluate at that value and it's not equal to 0, then the inverse of f is differentiable at that point. In other words, what I'm telling you here is these are the requirements that must be met in order for there to be a derivative. That's all there is. I haven't shown you how to find the derivative, okay? F needs to be continuous over the domain, and f needs to be differentiable at that point. That's the two requirements in plain English, okay? So now, if you meet those requirements, then you can find the derivative. So here's the derivative. Here's the rule. Derivative of an inverse function we're going to pretend that this is the inverse function. So you can give yourself a key. We're going to say g of x is the inverse function. Okay? You guys okay with that? So g of x is the inverse function. So g of x, you're going to be able to find it by taking 1 and dividing it by the derivative of f in terms of g of x, which means that f prime of g of x cannot be 0. Otherwise this wouldn't work. Agreed? It's on the denominator. I look at that and I'm going to be honest, I don't like it. It sounds complicated. Do you guys agree? Luckily for you, there's a way around this. I'm going to show you how to use this because maybe some of you guys are very formula driven. So I'm going to show you how to use it, how this works, and I'm going to show you my shortcut. Okay? Here's an example. We're going to let f of x equal to 1/4 x to the third plus x minus 1. What is the derivative of the inverse function when x equals to 3? So I'm giving you the function, but I'm telling you to find the derivative of the inverse and evaluate it at that value, correct? So in other words, here's what I'm asking you. The inverse of the derivative of the inverse function at 3. Do you guys agree? That's what I'm asking. Cool? No, we don't have to. How? You could, but that's just to determine if it's continuous and whatnot, right? So at this point, what they're gonna give you is it is gonna have an inverse. Like anything they give you, it's gonna have an inverse, guys. Okay? You don't have to check for that. That's pre-calc. They just want you to show your calculus. Okay? All right. So here's what we know. The inverse function, the derivative of it, would be at 1 over f prime of agreed? Just filling this information out. All I did was plug in. So the derivative of the inverse function at 3 is going to be 1 divided by the derivative of f at the inverse function of f evaluated at 3. You guys with me? Okay, all I did was plug in information. In order for us to solve this problem, we need to figure out what this is. Do you guys agree? So step 1, we need to figure out what that's equal to, right? Okay, so here's what we know. Very simply, Saf said earlier that when you have a function, so if you have your x and your y value, then on the inverse function, your x and your y value switch places. Agreed? You guys with me? Okay. So I meant to, oh no. I meant to say inverse here, I'm sorry. Do we know the point? If I'm telling you that that's 3, that represents the x-coordinate of the inverse. Agreed? Yes? So we know that we have x and then something. You guys with me? Which means that on the original function, that value is the y value. Correct? So then, since I don't have my inverse function, can I use the original function to figure out what x is, and that way I can figure out what y is? Yes? Okay. So if I have the y value of the original function, couldn't then you take this entire function and set it equal to 3? Yes? So then that means we have 1/4 x to the third plus x minus 1 equals to 3. Which means that 1/4 x to the third plus x minus 4 equals to 0. Right? I'm going to be honest with you, I don't like fractions at the beginning, so can I multiply by 4 both sides? So then this becomes x to the third plus 4x minus 16 equals to 0. Yes? And at this point you're like, well crap, this doesn't factor out. Right? When something didn't factor out in pre-cal, what would your last resort be? The rational zero test. Do you guys remember that one? I can't use the quadratic here because I have a cubic. And the rational zero test says find the factors of the leading coefficient, find the factors of the constant, and divide them. Right? Now, for time's sake, I'm going to tell you I did all that, and I found out that x equals to 2. Okay? Just for time's sake. So then that means that this is 2, right? Which then means that this is 2. Alright. Now I can finally get back to the problem. Okay, so I'm going to go down here and I'm going to continue the problem here. Inverse derivative of the inverse at 3 equals to 1 over derivative of f at what value? Do we know what this is equal to now? You guys with me? Okay. So then, do you have the derivative of the function, the original function? You don't, but you can easily find it. You guys agree? So I'm going to say the derivative of the inverse function at 3 would be 1 over, well, my original function, remember, was 1/4 x to the third plus x minus 1. I need to find the derivative of that. So 3 times 1/4 becomes 3/4 x squared. Agreed? Now I'm going to skip some step, and instead of putting an x, I'm going to put the 3 squared already. You guys with me? And then the derivative of x is 1. Cool? Yes? 3. Oh, I'm sorry. You're totally right. You caught me. Good. Thank you for not letting me go any further than that. Why would I put 2? Because I'm not solving for that yet. Like, I'm solving this right here, right? My mistake. Good catch. Cool? And this is why I don't like this formula, because I always get I always plug in the wrong thing. So now from here we're going to just simplify. The derivative of the inverse function at 3. Okay, so it's going to be 1 over something. So 2 squared is 4 times 3/4 is 3 plus 1 is 4. So that means that the derivative of the inverse function of x at 3 equals to 1/4. Alright, let me ask you something. Was that kind of, honestly, complicated? It's a lot of steps to it, right? if you like the formula, that's how the formula works. I'm going to show you an alternate way of doing this. You don't have to do it this way. We're going to take the exact same problem and we're going to solve it a different way. Okay? Here's what I do, because I get always, just like I did that mistake in class, I always do it, and I always get the wrong answer. I plug in the wrong thing. Here's what I know. The original problem was f of x equals to 1/4 x to the third plus x minus 1. I'm going to go back to pre-cal, and if I want to find the inverse, remember that the first step was to switch the x and the y. So I'm going to rewrite this as x equals to 1/4 y to the third plus y minus 1. You guys okay with that? Technically, like, eventually that is your inverse. Correct? What if I just differentiate that? Why not, right? Okay. The derivative of x is 1. The derivative of 1/4 y to the third becomes 3/4 y squared dy dx, because we're differentiating in terms of x, right? Plus the derivative of y is dy dx. Agreed? And the derivative of a constant is 0. So then couldn't I say then that dy dx times 3/4 y squared plus 1 equals to 1, right? Which means that dy dx equals to 1 divided by 3/4 y squared plus 1. You guys with me? Okay? All I did was implicit differentiation. The question was the derivative of that at 3, right? That was the question. Could I then just plug this in here? Could I just plug in the 3 in here? No. Because that's your x, and this is your y. Oh, I'm sorry. Because remember, this represents your x variable always. I don't care if it's the inverse or not. So you can't just plug in an x value for a y value. So how can I figure out my y value? How about even easier? Remember I did this? What if I plug in 3 in that one? For the x and solve for y. Agreed? Yes.
Why don't we plug in 3 at the start and then differentiate?
Because 3 at the start here. So you're saying plug in 3, but then you're just going to get a constant.
No. 3 on the...
Here?
After we find it.
So right here. So plug in 3. Can't think about that. Let's try it. I don't know. Let's see. I don't know if it's going to work. Okay, let me finish this and then we'll try it that way. I never thought about it that way. Okay? But here's the thing. We need to find out what y is. Do you guys agree? So if I plug in 3 in here, well, guess what? Isn't this the same problem we did earlier with the x's? Aren't we going to get 2? Do you guys recall that from previously? So then we know that we have the point 3, 2 present. Right? So that means that my y value is 2. So that means I can then come in and plug it in there. So then dy dx at the 3 value, right? Or you can even put the point if you want to, equals to 1 over 3/4 2 squared plus 1. And that looks exactly like the last thing we had on the previous page, right? 2 squared is 4 times 3/4 is 3 plus 1 is 1/4. Cool? Alright, let's try what you said, because I never really thought about it that way. Alright, this is the good part. Derivative of inverse trig. First, I'm just going to give you the formulas, you're just gonna have to memorize them, guys. There's 6. Since there's 6 trig ratios, there's 6 formulas. Let's start very simple with the derivative in terms of x of arc sine. So that means the inverse of sine, right? Of something. So let's call it u. That's going to be equal to the derivative of u divided by the square root of 1 minus u squared. Okay? The derivative of, in terms of x, of arc cosine, let's call it of u, guess what? It's the exact same thing as the derivative of arc sine, except that it's negative. So it's negative derivative of u over square root of 1 minus u squared. Square root of 1 minus u squared. So if you can memorize that one, then you technically know both of them. Just negate the cosine. Cool? Derivative in terms of x of arc tangent of u is equal to derivative of u over 1 plus u squared. Can you make a prediction of what the derivative of arc cotangent is? Same thing as tangent was negative. So the negative derivative of u divided by 1 plus u squared. And lastly, this is the ones that take me longer to memorize. Arc secant of u. It's the derivative of u divided by the absolute value of u times the square root of u squared minus 1. Which the arc cosecant is the same thing but negative. Yeah, that would not be fun. And that's the 6 rules you're going to have to memorize. But honestly, if you can memorize this 3, then you know the other 3 just by negating them. And there's proofs for all this on the book if you really want to find out how and where they came from. Go for it. If not, then you can just take them for as what they are and apply them. The tough part is remembering them. Using them is super easy. Check this out. Differentiate. Wait, I spelled that wrong. Differentiate. So let's say you have f of x equals to arc sine of 2x. Okay, we're going to be using this formula up here. So that means the derivative of f equals to, well, in our case, u is 2x, right? The derivative of 2x is 2 divided by the square root of 1 minus u squared. Well, if u was 2x, so minus 2x squared. Simplify it just a little bit, and I would call this a safe stop. Cool? Like, don't do anything else. Like, stop there. There's no need to. Let's just kind of forget that for the moment, okay? Alright, let's try one more together, and then I'll let you try some on your own. So let's say g of x equals to arc tangent of 3x. So the derivative of g, or g prime of x, would be, okay, so we need the tangent rule. So we need to find the derivative of, in this case, 3x. So the derivative of 3x is 3 over, according to the rule, it says 1 plus u squared, so 1 plus 3x squared. So it simplifies to be 3 over 1 plus 9x squared. And I would stop right there. Cool? Alright, you guys can try this one. C, let's see, arcsine of the square root of x. You can try arcsecant of e to the 2x. And last one, I'm going to throw in there more rules for you so you can not forget them. How about f of x equals to arcsine of x plus x times the square root of 1 minus x squared. Yes, I'm sorry. F of x equals, my mistake. So differentiate those three functions. C and D, if you use the rules, you should be fine. E, I'm throwing back old rules so you don't forget them. Okay? So that's technically all I got for you guys today. So practice those. Homework for tonight. If you're watching the video, here it is.